Okay, good evening, everyone. I will start now. So basically, I'll just tell you the format in which we will cover this revision session for week 1, 2, and 4. So I will cover firstly the important concepts, week 1, week 2, and week 4. Thereafter, I will also cover certain questions which I found tricky in the GAs and in some previous question papers, and thereafter I will leave it to the forum. You can ask me the doubts. Meanwhile, when I will be covering the concepts in that also, if you got any doubt, please interject and I'll clarify it there. So I'll just share my screen. Is my screen visible, Bhavya?
Yes, sir.
Okay. So we go straight away to week 1. So week 1, the important concepts which were covered was the first was the MP neuron. So we have to remember the MP neuron takes Boolean inputs and the output is also Boolean. So it will add on the inputs, and if the gx is greater than equal to theta, please remember this greater than equal to, and in please see the question, if only greater than is given, then your theta will change, and this theta is threshold. So if g of x is greater than equal to theta, then y is 1, else it is 0. So that is for the MP neuron. In that, the question can be asked like to find the threshold for some values. You are given x1, x2, and the output is given. So by using this concept, you can easily find the threshold. So again, I will repeat in the question, please see whether it is greater than equal to or it is greater only.
Hi, Lilith. Can you increase the volume? Increase the size, the font
Yeah.
size. Zoom in a
Yes.
little bit.
Yes.
Yeah, thanks.
Yeah.
And also, can you just repeat what you said? The greater than and equal to this, please.
Okay. What I said that in the MP neuron, if you see, if it is gx greater than equal to theta, this is threshold. Okay. In some questions, you may be asked that okay, x values, x1, x2 values are this is the output, and there it is given that gx greater than theta only. Okay, if you see some previous year question papers, in that it is not given greater than equal to. So your theta, that threshold value will change. I'll just give you an example. For example, there are 10 inputs and this is an AND function, and your gx will be 1 only, for example, if y is equal to 1, if gx greater than equal to theta. If it is greater than equal to theta, then your value becomes, will be the threshold for AND? Anyone? Bhavya?
10.
Then it is, yeah. So then it becomes 10. And in case it is only greater than theta, then what will be the value of threshold?
11.
9.
Sorry.
Okay, so that's why I just, for your benefit, that's why what I'm pointing out, that please see the question, whether it is greater than equal to or it is greater than. Okay. Then we come to perceptron. Perceptron fx y is equal to 1 if wi into xi is greater than equal to 0. See here, I has become 0 and it is up to n. Here the threshold has been taken inside only. So this will become w0 x0 plus w1 x1 plus w2 x2 plus up to wn xn greater than equal to 0. This x0 always remains 1. Please remember this. And this w0 is the bias. So this also can be written as w1 x1 plus w2 x2 up to wn xn greater than equal to minus bias, because your x0 is 1 So this is nothing but what we say threshold. So threshold is equal to minus of bias. So in some question, if you are asked, there is a perceptron and input values are there, and you are asked that find the threshold, then calculate the bias, and the threshold will be the minus of the bias. Is it clear? Any doubt in this? Anand?
No, Lilith.
Yeah. Okay. Now we come to perceptron learning algorithm, because it will be handy in some questions where data is given and you are asked that how many iterations the W's will converge and all that. So for the perceptron learning algorithm, if there is a point which is positive, but it has been identified as n, then we update W is equal to W plus X. And in case it is a negative point and it has been identified as positive, then update rule is W minus X. So this we have to remember. We will solve one question on this concept. Now in the lecture, this was covered conceptually also, graphically also, that how it happens. So here I will cover one more concept, that if the weight vector, for example, here is W, then the decision boundary is always perpendicular to this W. So in this diagram, if we see P1, P2, P3, they are positive points. So the angle between W and all the positive points is always less than 90 degree. Whereas the angle between this W and all the negative points is always more than 90 degree for positive and for negative. So whenever there is a, for example, we take the first case, that if there is a positive point, however, it has been misclassified as negative, then we do W is equal to W plus X. So original W is here. This is the point which has been incorrectly classified. So we add this X to this W. So this becomes your new W. And similarly, if a negative data point has been classified as positive, then we update W is equal to W minus X. So please remember this concept. W is equal to W plus X and W is equal to W minus X for both the cases. Then there was a question in, I think, in the GA, that a Boolean function maps 0 to 1 and to 0 to 1. How many linearly separable functions are there when n is equal to 1? So here, first of all, we have to remember that number of Boolean functions, including both linearly separable and non-linearly, is 2 to power n. So here n is equal to 1. So your number of Boolean functions will be 4. And if we take y is equal to fx, we take x 0, 1, 0, 1, then y can take only, for example, this is x 0, 0, 1, 1, then y can take 0, 0, 0, 1, 0, 1. And if you plot this on a graph, then you can make out that they all are linearly separable. So like I mentioned, here I have given one example for a perceptron algorithm example. The similar kind of questions, they have been asked in the graded assignment also and in previous year papers also. So these are the values x1, x2, y. x1 minus 1, x2 minus 1, y is 0. x1 minus 1, x2 plus 1, y is 1. x1 1 minus 1, 1, 1, 1, 1. So this is nothing but it is a OR function. And the same I have plotted here also. So how a perceptron algorithm works? So first, what do? We initialize W with all zeros. So here we have initialized W0, which is the bias, W1, W2 with all zeros. X0 is always 1, remember that. So then we come to the first point. So first point is negative. We do summation of Wxi. For this W, this will become 0. And now this meets a requirement. Condition 0 is greater than equal to 0. So this point will be classified as positive. So this is the case where a negative point has been classified as positive. So what do? We update the W by doing W is equal to W minus X. So new W will become minus 1, 1, 1. For the second point we come, second point is positive. Now with this new W, we take summation of Wxi. Remember, always take x0 as 1. So here this will become minus 1, which is less than 0. So this is also misclassified. It will be classified as negative. So we do updation for this, and this is a case where positive point has been classified as negative. We do W is equal to W plus X. So the new W will become 0, 0, 2. Now we come to the third point, which is positive. We do Wixi, it becomes minus 2. Again incorrect, so we update. So new W will become W is equal to W plus X. The value is 1, 1, 1. We come to fourth point, do summation. Summation becomes 3. So this is correctly classified. So there is no update here. Now we go to next iteration. So we have covered all the 4 points. Now with this W, now we check. So first point N, our W is 1, 1, 1. We multiply, it comes minus 1. So it is correctly classified as N. Second point P, Wxi is equal to 1, which is greater than equal to 0. So it will also be correctly classified as positive. Third point P, Wxi is equal to again 1, correctly classified. Fourth point P, Wxi is equal to 3, correctly classified. So this 1, 1, 1 is the value. And here if you are asked that what is the threshold, so like I mentioned earlier, threshold will be minus of bias. Bias is 1, so threshold becomes your minus 1. And which you can see here in the graph also intuitively that these are the 3 points. This line cannot pass from here. So this line threshold has come to minus 1. And this is your W vector. Okay, so there is another question in this. It is a concept question. The 4 points have been given, x1, x2, x3, and x4. And the perceptron rule has been given. And they have given that decision boundary, it passes from origin and through a point D, which is 0.51. which I have marked here. So this is a point 0.51. This is the decision boundary. The weight factor is initialized to W is equal to W0, W1, with W0 is equal to minus 1. So what is the value of W1? Can somebody tell me back up again, quick, conceptually, how should we approach this problem? Bhavya? Anand, am I audible?
Yeah, you are.
Yeah.
Okay. So like I had covered earlier, that weight vector is orthogonal to your decision boundary. So what does it mean? It means weight into this decision boundary, if we take the dot product, it will always be 0. So this W0, W1 is minus 1. Second point, we have to calculate W1 dot 0.51 is equal to 0. So from here it will become minus 0.5 plus W1 is equal to 0. Therefore, W1 is equal to 0.5. Okay. So why I included this question, you might be facing a question which looks long, complex, but if you apply your concept, then the answer will be short. So idea is to get the concept behind that question. What is the concept which is being used? Okay, so this I have covered. Second, there is a question in the P by P what they have asked, that initial W has been given. You have been given some data x1, x2, y, for example, something like this, which I covered earlier. And initial, for example, they have given W is equal to -1 or 1. And then you, after doing those iterations, you find the new W, which is meeting the requirement and which makes the decision boundary. So a question may be asked that what is the angle between old W and the new W? So please remember from our mathematics foundations that cos theta is equal to W1, for example, I say, and this is W2, W1 dot W2 and norm of W1 and norm of W2. So this is how these values are available to us. So theta will become cos inverse of this value. Okay, so there is a question, I think, in the graded assignment or in the PYP on the same. This document I will share with all of you after the session. Now we come to the, so this was about the week 1. Anybody, any doubt about the concepts of week 1?
So Lalit, this cos theta is equals to what was that? Can you just go to that?
Cos theta is W1 dot W2 divided by norm of W1 dot W2. It is nothing. For example, I give you an example. 1 minus 1, for example, was initial, and we found -1 and 1. And this norm is of W1 is the square root of values. For example, here it will become 1 square plus 1 square. W2 also becomes root of 1 square plus 1 square. And so this will come root 2 into root 2. This will become -1 divided by 2. So -2 by 2, this is -1. So theta will be cos inverse of -1.
Okay.
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 So remember this formula.
Okay, got it.
Yeah.
Thanks.
So shall we move to week 2? Okay, so I assume there is no doubt about any concept of week 1. So we go to week 2. So in the week 2, the important concepts which have been covered is... Hello, I'll request everyone to keep your mics mute, please. Okay. So week 2, the important concept, the first concept was the sigmoid function. Sigmoid function is fx is equal to 1 divided by 1 plus e to power minus z. This is the sigmoid function, e to power minus, for example, something, z. Now here only I will cover because there might be some questions here. If you see, first of all, the maximum value of a sigmoid function can be only 1. Because if this z becomes infinity, then this entire value becomes 0. So, and max will become 1. The minimum value is 0 because the maximum value which can come here will be what? Anyone?
Could you please repeat?
So I was mentioning what can be the maximum value of sigmoid and what can be the minimum value of the sigmoid.
It's 1 and 0.
1 and 0. Okay, very nice. Okay, so some questions on this which have been asked in the GA, and if W is positive, then this W, it controls the steepness. So for a normal sigmoid, if W is positive and if it increases, your steepness increases. What do I mean by steepness increases? That if this was the original one, sigmoid, now when we increase W, your steepness will increase. If we increase the bias, then this function will move towards left. It will come here. So this is for a standard case when W is positive. When W is negative, opposite happens. that when W decreases, then steepness increases, and when bias increases, then slope will shift to the right. So please remember this. There might be a question on this. And if you don't remember also, you can do it mathematically by taking some values, and you can easily find how the slope is shifting. The second important concept of this week 2 was the gradient descent. So gradient descent update rule is Wt plus 1 is equal to Wt minus eta into the gradient of loss at that Wt, and same formula for the bias also. Now when we come to sigmoid function, please remember these two which have been derived by the instructor during the course. This delta W is equal to fx minus y into fx into 1 minus fx into x. For delta B, it remains the same, minus x. There is no x here. And these two formulas, they will come handy throughout the course when we will be doing the RNN. Wherever we are using the sigmoid function, we will be using this delta this. So it is important to remember these two formulas. Now, based on this concept, there will be questions based on this concept for the calculations. So I have taken a question from earlier previous question paper. So the question is, consider a sigmoid neuron that takes in an input vector x of size 100. All the elements in x are 1. The parameters weights and bias are initialized to 1. That is Wi b is equal to 1 for all i's. Suppose we randomly set 80% of the inputs to 0. Assume the true label y is equal to 0. And the loss function is mean squared error loss. Update the parameters by running gradient descent algorithm with the learning rate eta is equal to 0.1 for 3 iterations. Enter the sum of updated parameters. In case of insufficient information, enter your answer as -1. Okay, so how to approach this problem? We know they have given W is equal to 1, they have given B is equal to 1, and they have given true level y is equal to 0. They have also given loss function is mean squared error, that is 1 by 2 y hat minus y squared. Now they have given 80% of the x is 0 and 20% means rest 20 are 1. So what do we do? How do we find y hat? Y hat is equal to 1 divided by, we are using sigmoid, e to power minus wi xi plus b. So here 80% of the values are 0, so only x will be 20. It is the summation here, summation. So this will become 1 divided by 1 plus e minus. So w is 1, x 20, so this will become 21, and bias value is 1. Okay, sorry, 20 plus 1. So this will become 1 plus e to power minus 21. Now, whenever this value is very high here, e to power minus 21, this sigmoid value starts going to closing to 1. This you can check. In fact, after the value of around, if this is z, after around 5, 6, it starts converging towards 1. So this 21 is high, so this will become 1. So y hat is 1, which is incorrect. So what do we have to do? We have to update the w and b. We know the formula for gradient descent update. W is equal to w minus eta into delta of w. Now delta of w for a sigmoid, that's why I said we have to remember this formula, fx minus y, fx 1 minus fx into x. So see here 1 minus fx and our fx is 1. So 1 minus fx, this becomes 0 and this entire value becomes 0. It means this value becomes 0, so there is no update for w. Similarly, there will not be update for bias also. So after the 3 iterations, there are no updates. So in the question, they have asked the sum of upgraded parameters. So sum of upgrade parameters is there are 100 W's and there is one B. W remains 1, B remains 1, and answer is 101. Is this clear? Any doubt in this question?
A small doubt, like how y hat is like you are saying incorrect. So I'm getting confused in that area.
Okay, so y hat here we have calculated 1
Yes, yes.
and given true level y is 0.
Okay, okay. You compared and said it's incorrect. Okay,
Yes. So we carry the
got it.
we do the update when your y hat is not matching with the true way.
Got it, got it. Thank you.
Okay. So this question also I specifically chose because it looks very long, complex, but when you apply the concept, then the answer becomes very very easy to find, and then very few steps. So from week 2,
Sir, I have a small doubt.
yes,
So in this question, for fx you took y hat, right?
fx is y hat.
Okay, correct.
Because here they have given in the question that we are using the sigmoid neuron.
Correct. Okay.
Okay, consider a sigmoid neuron.
Okay, sir. Got it.
Okay. So from this weak point of view, important things are to remember are this. And delta B is same other than so these are the two things which you have to remember, and they are for sigmoid. Okay. Now let's consider another question. Okay, again, consider a sigmoid neuron that takes an input vector x 1 minus 1 1 minus 1. Weight vector theta is initialized to minus 1 1 minus 1 1. The output from the sigmoid neuron is y hat. We are using sigmoid neuron. Suppose we use the mean square error function as a loss. Update the weight vector once by running the gradient descent algorithm with eta is equal to 20. Assume the true level y is equal to 1. And what is the new loss value? So I will cover the steps one by one here. How to approach these kind of questions. You have been given x, okay, something. You have been given w. You have been given y. Let's see what is the values of 1 minus 1, 1 minus 1. Right, w is minus 1, 1, minus 1. Y is equal to 1. Okay, so steps again. Please remember these steps. So first, what do you do? First, find y hat. How we will find y hat? Y hat they have given is equal to 1 divided by 1 plus e to power minus w transpose into x. So do w transpose x. If you do, this will come minus 1, minus 1, minus 1, minus 1 is equal to minus 4. So this will come 1 plus e to power 4. Okay, so first you calculate the WT, this y hat. So y hat, for example, in this case it has come 0.018. Second step, find the loss. Now you have to compare y hat, y, and so it's not second will be update w and b. For that, what you will need? You will need w, and you will need gradient of b. So gradient of w will remain same, fx minus y into fx into 1 minus fx into x. So this you calculate. Now here is the x. This is a vector like this, 1 minus 1, 1 minus 1. Here you will get some value from here. You multiply this, so you will get delta w, which will be a vector. And now nu w will become w minus nu into this delta w. N has been given 20. You multiply this, so you will get nu w. Let's call it w dash. Similarly, we will get delta b, which will be fx minus y into fx into 1 minus fx. So this will be a value. So here the b is not there in the question, so we don't have to calculate. Now with this w, you calculate nu y hat. And from that nu y hat, the question has asked us what is the new loss value. So new loss value will be half into y hat minus y square. So these are the steps. Same I have done here. First I calculated w2x, which came minus 4, y hat became 0.018. I calculated the gradient of loss with respect to w. So y hat minus y hat 1 minus y hat came minus 0.017 multiplied by x. I got delta w this. So new w will become w minus 20 into this. So this is the new w value. From this new w value, I calculated the y hat, which has come 0.066. With this y hat, I found the loss, which has come 0.436. So these are the steps. Please remember, the question can come, and this how you have to approach the question. Any doubt on any step here?
No, no doubt.
Okay. So now please
I
remember.
have a doubt here,
Yeah.
but I'd like to ask you that in some of the questions, I'm not talking about this kind of questions, especially in week 3 when we have feed forward neural network. So
Yeah.
the weights are actually in
Okay.
usually they are in
So
square.
yeah, so that okay, week 3 has already been covered. However, once we finish
No,
week
no.
1, week 2,
Yeah,
and week
I'm
4,
not, it's a simple thing. I mean, it's not
Yeah.
something explicit. So the weights are actually the square matrix usually, and so should we be taking W transpose X or should we be taking WX? Because that has been, I mean, I see some questions, it is simply as WX. Here it is mentioned as W transpose X, but at some questions it is not mentioned.
okay. So I will cover something here. See, week 1 and week 2 are basically to build your concepts to take you to week 3. Okay, that's why here we have not got the square matrices and anything. Here basically the concepts of your sigmoid, derivative of sigmoid, gradient descent, how the updates are taking place, how the loss values are calculated, how the loss is being used to update. So it is only to build your concepts here, these. Okay. Now, I would like to add on here, in this question, they might have given you some bias also. Okay. Here, the bias has not been given. Bias might have been given, and then also we have to approach the question in the similar way.
I think you didn't get my point. I mean, what I'm asking you is the issue with the dimension. Like in the courses, like in generally, if I am constructing neural networks or anything, but I take from input layer to hidden layer. But in the courses, they take from hidden layer to input layer because they consider weight vectors to be the column matrix rather than the row matrix. That is what I'm asking.
Yes, yes. So I will cover this again once we finish week 4. I will come to this
Okay.
point and why it is being done.
Yeah.
Okay. Okay.
I do understand why it is done. It's just that, like, what should be the norm to solve the question? That is what I just wanted.
Okay. Okay. So I will. Okay. Now you're asking, so I'll cover it here only.
Yeah.
See.
Just like one
Okay.
general norm that I
Yeah,
should
yeah.
follow in exam as well.
See, in the course, we have taken a norm. For example, this is your input layer. It is H0, and I'll give you example of 5 into 1. This is first hidden layer. This is A1, H1. For example, it is 4 into 1. This is A2, H2. This is A3, H3. Now here, what you are saying that W1 has been taken as 4 into 5. You're writing this, you're saying this only?
No, I usually take as yeah, it is taken as 4 into 5. Yes, 4 into 5.
Okay. So in the course, please remember we are following this convention. Otherwise, when you build your own network, nobody stops you from using 5 into 4. However, remember, when you do the forward propagation, you are using 5 into 4, then you will do WT transpose. Okay. When you do the back propagation, that time you will use W only.
Right.
Okay. When we are using 4 into 5, so in the forward propagation, we use W. And when we do the back propagation, that time we use WT. This is the only difference. So both the conventions can be followed. They have got their own advantages, disadvantages. Sometimes your forward propagation is more costly. Sometimes your back propagation is more costly. So depending on the problem, you'll be having this. Okay.
So as per the course, I should go for like
Yes.
if W is given, W transpose X.
Yeah. Yes. For the course, okay, you follow 4 into 5.
Yeah. Okay.
Okay.
Now the only thing that I want to confirm is that, like, we have to take W transpose and then X. So this should be the norm.
Yes. See here in the question, it is given clearly. Okay. And the questions
in this question it is given. Yeah. And some questions that I solved, there was not mentioned. So I'm assuming that even if it is not mentioned, I should take as W transpose and then multiply X.
See, then we should be smart enough to make out also. For example, if W1 has been given like this, 1, 1, 1, 1. Okay.
Usually it's the problem when there is a square matrix, right? You don't know that.
No. Here also it will make a difference. We should be smart enough that we have to, for example, this is W1 and this is your X1. For example, then what you will do? Here I will not use transpose.
Yeah,
Here I will do WX only. Okay. So we have to see the context of in the question and then apply our calculation. Okay.
That's okay. That is understandable. But the problem comes when the weight is like in a square matrix, and then you are taking X. So even if you take transpose, the values are going to change. Solution wise, so you will get solution in both the case, but one solution will be there, another solution will be wrong. That's the problem I'm facing.
Okay. So I will clarify here only. If you know it is 3 by 3 and 3 by 3, then you can do W and W transpose, the problem and confusion which you are talking about.
Yeah.
When the dimensions are not same. Okay. So then it will depend on the W size. For example, here W1, if you take 5 into 4, then it will be W1T into H0. And if you take 4 into 5, then it will be W1 into H0. Because the multiplication of this has to match the size of this.
Right.
Okay.
Right.
So this is a week 3 concept, and we can discuss it later on once we finish these 3 weeks. Okay. Now another important concept which was covered, and there have been few questions on this concept in the PYPs and in the GAs are the tower functions. So remember, for the tower functions, to build one 1D tower, we need 3 neurons. Okay, just like this. With different values we pass and we make one tower. And for making 2 towers, we add 2 more neurons. We pass more value. So this becomes 5. To make 3 neurons, we add more and we get 3 neurons. So generally, you can say that to build n towers, 1D towers, we will have how many? 2n plus 1. Is that clear? Anybody? Any doubt in this? So to build 100 towers, there is a question, I think, in the GA. We will have 201 neurons. Similarly, when we build 2D towers, then one tower is made by 5 neurons. There are 5 neurons like this. And there's an output neuron. And by this, we get a 1 3D tower. Okay. Now, to make n towers, we will need 5n plus 1. And for this, I'll share this document. I'm giving a reference also. You can go through this reference where this topic has been covered in detail. So just wanted to cover these numbers if the question comes, how to approach these questions. Okay, this I have covered the steps. Now, okay, I have finished like a week 2. In case any question about week 2 in any concept.
No doubt.
Okay, thank you. So we move to week 4. So week 4, now we come to the update rule of W and bias. So we see both the updates, they depend on the gradient. The gradients are nothing but, okay, they are the derivatives. Now we know from our mathematical concepts that whenever the slope is steep, your derivative will be high. When it is gentle, your derivative will be less. So taking the same concept here, whenever the loss surface is steep, you will have this value delta LW will be large and updates will be large. At gentle surfaces, this gradient will be less, therefore there will be small updates. So this is a problem which we want to solve, that if we have come to a gentle surface, there are small updates, it is taking a lot of time, so how to expedite it? So the intuition came that we are depending only on the present gradient. Why not to carry the momentum from the past gradients and it fructified in a gradient descent algorithm called momentum gradient descent algorithm. So before I move to MGD, I'll cover the contours also here because there are questions on the contours. So in the contours, the first thing is how to make out that which is a local minima and which is a local maximum. So this, please remember, see the contour. In the contour, the loss values are written. So if the loss values are decreasing from out to in, it means this is a local minima. If the loss values are decreasing outward, then it is a local maxima. Is that clear? Any doubt in this?
No doubt.
Okay.
Sir,
very
can
nice.
you repeat once again this
Okay.
contour concept?
Okay. So contour, the first concept is that in a contour, how to make out that this contour has got a local minima or a local maxima. Okay. So we have to see the loss values. If the loss values, see, this is a loss surface. If the loss values are decreasing from outward to inward, then it is a local minima. Okay.
Okay.
And if the loss values are increasing from outward to inward, then it is a local maxima.
Okay, got it, sir.
Okay. Second is that in a contour, how to identify which is a steep region and which is a gentle region. So like I mentioned earlier, in the steep region, you have got more updates. So here the distance between these contour lines will be less. So this is a steep region. Whereas in the gentle, your distance between these two lines will be more. So this is a gentle region. So these are the two concepts of the contours.
Sorry, please could you repeat once? Sorry.
Okay. So I will cover on a new page. Shall I repeat both concepts or only one concept? Okay, so this is a contour, for example.
Second concept alone.
You have been given this contour, for example, and this is for one parameter, and this is another parameter. Okay, this is W, and this is bias. So first concept was that okay, loss value should be decreasing. So that we have done. Okay, I assume. Now here they ask that which parameter is dense. Which parameter is dense? Can you tell me?
So W.
Yes, because here the updates for W are more. Okay, because the lines are closer. Okay, and B is sparse. Okay, so this is the concept. How to read it? Or we can say, or in the terms of surfaces, this is a gentle surface. Gentle surface means if I draw in 2D, it is like this. Whereas this surface here, it is like this. Okay, stay. Am I clear now?
Yeah, clear.
Okay. Yeah. So now we have covered this. So now we come to momentum gradient descent. So the intuition already I have covered that we have to take the momentum of the path gradients. So for this, what do we do? We define a variable called ut, which is equivalent to beta into ut minus 1 plus gradient of loss at wt. And we update weight wt plus 1, wt minus eta into this ut. Now remember, this ut which is there, it is for both if you have got weight and if you have got bias. And initially we assign u minus 1 which is there equal to 0. Beta value is between 0 and 1. Generally it is taken 0.9. So if you take the first step, first iteration, u0 will become delta w0, u1 will become beta into delta w0 plus delta of w1. In u2, it will become beta square of delta w0 plus beta this. So what is happening that we are carrying the momentums of the past gradients also. And as we are moving forward, this value is decaying because beta is less than 1. So we know that 0.9 square, then 3 times, then 4 and 5. So this is decays. But we are carrying this momentum. And using this, we are updating our weight factor. So what is the advantage conceptually of this momentum gradient descent? That and gentle surfaces also, due to my strong momentum which I am building, I will have more updates in gentle regions also. But there is a big disadvantage also here that as we reach a local minima, for example, here it was my local minima, and this my momentum gradient descent is taking place. Now, due to its high velocity, it jumps, then it will come back, then again it will jump. So it will take time to converge. However, in all the cases, MGD will converge faster than a normal gradient descent. So remember this. Okay, first of all, know the reason that why it is doing these oscillations, and still it will converge faster than normal GD. And please try to remember these two. In quiz 1, there are not so many formulas to remember. Remember this ut is equal to beta into ut minus 1 plus gradient of weight t, and update rule is wt plus 1 wt minus nu into ut. So this will come handy to you in some of the questions. It can come. And this ut in some literatures online, if you will see, it is also known as velocity momentum vector. Now, the second concept came that these are the disadvantages. Oscillations around local minima already are covered. Takes a lot of U-turn. Despite these U-turns, it still converges faster than vanilla. Now, how to fix this problem? So with this, the Nesterov, he came with an algorithm which is known as Nesterov accelerated gradient, also known as Nesterov accelerator. So the basic idea of this algo is that before you calculate, like in this momentum, we are calculating WT. So he said, well, before you leap, look back. So he calculates this gradient at WT minus of this value. So by doing this, he is not moving, he's not overshooting, he's doing the gradient here only. So for the energy, the update rule is ut is equal to beta ut minus 1. You are calculating gradient at wt minus beta ut minus 1. Update rule remains for w remains the same. Beta again between 0 and 1, generally 0.9. We take u minus 1 is equal to 0. So this is the Nesterov acceleration. Some theory looking ahead helps energy in correcting its course quicker than MGD, hence the oscillations are smaller and the chances of escaping the minimum value are also smaller. Now, shall we do one question based on this energy before we move to the final part?
Yeah,
Yes.
yes.
Yeah, okay. So I have taken a question from the graded assignment. So in a graded assignment, the question is consider a sigmoid neuron. So these are the points where we have to focus. Sigmoid neuron, single input, value of input x is equal to 0.5 and the true output y is equal to 1. The weight and bias of the neuron are initialized to 5 and minus 5. Nesterov accelerated gradient descent algorithm with beta is equal to 0.9 and eta is equal to 0.1. Loss is mean square error. It is trained for 10 iterations. Iteration starts from 0. Parameters at 10th iteration means t is equal to 9 is u8 is equal to 0.8 for both w and bias. w9 is equal to 2.5, b9 is equal to 0. Calculate the gradient of look ahead value for the next weight update. So the question is asking this, we have to focus the gradient of look ahead value for the next weight update. So we know that in a Nesterov this, ut is equal to beta ut minus 1 plus gradient at wt minus beta ut minus 1. So in the question we have to calculate this gradient. Okay. So we take u9 is equal to beta u8 plus gradient of w9 plus minus beta into u. Now remember, this is a sigmoid neuron. So for a sigmoid neuron, your derivative or the gradient formula is y hat minus y hat 1 minus y hat into x. And y hat depends on both w and b. So this value will depend on, this gradient is depending on b and w both. So what do we do? First we find the w for this gradient. So w becomes w9 minus beta into u8 and value is 2.5 minus 0.9 into 0.8. We put values, we find the value of w 1.78. For beta will become beta 9 minus beta into u8. This will becomes minus 0.72. We find y hat now at this w and b, which comes 0.54. Now once we have got this, now my gradient calculation becomes easy. Now gradient, I just have to put the values into fx minus 1 into fx into 1 minus fx into x. In the question they have asked for w. So this is the formula. I just put the values of I hat and I get the answer. So this question, any doubt, anyone in this?
Sir, the formula for updated weight is WT minus neta times WT, right?
So here, in the question, they are not asking for the update. They are asking gradient of look ahead value for the next iteration.
Okay.
Okay, so I will cover again here. Slightly, the concept is slightly tricky. So for benefit of all, I will cover it again.
Yeah.
So the question is, we have done, for example, iteration starts from 0, parameter at t is equal to 9. So we are at 9. Okay. So U9 will become beta into U8 plus gradient W9 minus beta into U8. So this is the gradient which is look ahead, and we have been asked to find this. Is this clear?
Yes.
Okay. Now we know that gradient of this value which we are finding, it is a sigmoid. So for sigmoid, the formula of gradient W is fx minus y, fx 1 minus fx into x. Okay, so I have to calculate fx. Now fx is nothing, is 1 plus e to power minus w into x plus b. Is this clear?
Yes, sir.
So my fx depends both on this w and b. Okay. Now effective w here, when I'm looking ahead, is w9 minus beta. Beta value is 0.9. U8 value they have given me 0.8. W9 they have given 2.5. So this becomes 1.78 for this gradient. And
Okay.
my this bias also is determining the fx. So I have to take the bias also for this. So bias will become B9, which has been given 0 in this case, minus 0.9 into 0.8. It becomes minus 0.72.
Okay.
So
Got it, sir.
by using these values, I calculate fx. I'll get some fx value. And now by using this value, I calculate this w, which has been asked. Okay.
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 Yes.
Yeah. Okay. Now we come to another concept, like last portion of week 4, vanilla gradient descent, stochastic gradient descent, and mini batch gradient descent. So remember, in vanilla gradient descent, the update in one epoch is like one iteration. So in vanilla gradient descent, full data is taken and only one update takes place. So for example, if my data set contains 10,000 data points, in one epoch, only one update will take place. In the stochastic gradient descent, there is one update for every data point. So again, taking the same example, if I've got 10,000 data points, on one epoch, how many updates will be there for stochastic gradient descent? 10,000.
10,000.
Yeah. In mini batch gradient descent, what do? We decide that we will pass the data batch wise. For example, I make a batch of around 1,000. So in one epoch, how many times these batches will be passed? I got 10,000. There is a batch of 1,000. So there will be 10 batches.
Yes, sir.
Okay. And for every batch, the update will take place. So in one epoch, you can say that there will be T by K updates, where T is the total number of data points, and K is the number of data points in one batch. Okay, easy to remember. There have been questions in the graded assignments, and these questions, remember, when you approach the quiz paper, please read between the lines what has been asked, because in one question they might be combining, one or two more concepts. Okay, so remember the concepts only. So this I covered. Okay, any question on this? The number of updates, vanilla gradient descent, stochastic gradient descent, mini batch gradient descent.
No, no doubt.
Okay, okay. So this question I have covered. Question one. This was for myself. Okay, so now we have covered the concepts of week 1, week 2, and week 4. Now, any question about the concepts? And now you can ask me about the concepts of week 3 also, in case your concepts are not clear. Any little doubt? Okay.
Sir, which one is the best out of all these gradient descent? Is there any kind of
Okay.
idea which you get?
Okay, see, like I mentioned, that all these weeks, okay, they are building our concepts, okay. So we started with basic gradient descent, then we understood that basic gradient descent at gentle surfaces, it might take a lot of time. Your eta will also define your update rates. Then we came to momentum, then we came to, Nesterov. Now, in the coming weeks, okay, we will move ahead also. Okay, so these are like the optimizers. We are optimizing the algorithms. So we will come, okay, with AdaGrad, okay, then we'll come with the Adam, we'll come with NADAM. So in week 5, okay, those concepts will be covered. So by default, okay, Adam, 90% of the times Adam is used, but you can make your own customized also. Okay, and depending on the problem, in which sphere, which domain you're working, so that, okay, you can select. Okay.
Okay, sir.
So I will suggest that you build your concepts, okay, because in case I'm telling you from my own experience, the first 4 weeks of deep learning are slightly difficult, and when your concepts they become clear, you will sail through like anything. So you have to remember what is softmax, what is sigmoid, when do we use softmax, when are we using sigmoid, what is the loss function which we will use. So automatically things will start building up. So in case, okay, you have got any doubt from week 3 also, you can ask me. I'll be happy to answer.
Have you covered the week 3 revision kind of?
Week 3 revision, yesterday it was done, okay, by Nitin.
Okay.
So there was a special revision. It has been done yesterday. So in case, okay, there is any doubt, you can ask me. And now I will leave to the forum. Now you can ask me any question. I covered the concepts, and now you can ask me.
Sir, is there any back propagation? Can you explain it?
Okay.
Yeah.
Question.
1 minute.
With question.
Okay. So you have given me the.
Excuse me.
Okay. So I will cover quickly the basic concepts of week 3. Okay.
Yes, sir. It will be better if we cover it using a question.
Okay. Can you give me some question from PYT somewhere?
As of now, I don't have any, sir. But it's okay. Then we can continue with concept, and meanwhile, I can
GA3.
find question.
Yeah. Okay. So I will cover the concept here, and I'll give you the clarity. I'll select some different sizes. This is input layer. This is hidden 1. This is hidden 2. This is output layer. In hidden, we are using sigmoid. Here we are using sigmoid. Here we are using softmax. Size is 5 into 1. This is 4 into 1. This is 3 into 1. This is 2 into 1. Okay. This is A1. This is H1. This is A2. This is H2. This is A3. This is H3. And this is H0, which is input. forward propagation, A1, here is W1, W2, W3. Size of W1 is 4 into 5, W2 is 3 into 4, W3 is 2 into 3. Bias 1 size will be 4 into 1, bias 2 size will be 3 into 1, bias 3 size will be 2 into 1. Okay, setup is clear? So now we do forward prop. So A1 is W1 dot H0 plus B1 and H1 is equal to sigmoid of A1. A2 is equal to W2 dot H1 plus B2. H2 is sigmoid of A2. A3 is equal to W3 dot H2 plus B3 and H3 is equal to softmax of A3. This is clear? Any doubt? Anyone in this? And we'll solve this question also. Okay. We'll take
Yes.
x is equal to 0, 0, 1, 0, 0 and we will take actual y is equal to 1 and 0. So we'll solve this. Okay. And initially we will take all w's and all biases having all 1 values. Okay. So this is forward prop is clear. So now can we calculate forward prop here?
Yes.
Can somebody give me quickly the values?
Okay.
What will be the H0 value? H0?
X0 is the input. X0 is nothing but the input.
Okay, okay.
It's 2. A1 should be 2.
No. A1 will be size of 4 into 1.
Okay.
Okay. So just to, okay, what is the W1 size? 4 into 5?
Yeah.
What is H0? 0, 0, 1, 0, 0 plus B size is 4.
Hmm.
So this becomes 1 plus 1, 2. 1 plus 1, 2. 2, 2. Is this clear?
Yeah. Yes, sir.
Now H1, find out the sigmoid of this. 2. Bhave, can you give me the value of sigmoid 2?
Sorry, sir.
Bhave, can you give me the sigmoid value of 2, please?
Sigmoid value of 2.
Yeah.
Uh, 0.8.
How much?
0.8.
0.8. Okay.
Huh.
Okay. Okay. So this is 0.8, 0.8, 0.8, 0.8. Okay. Now can we calculate A2? Anyone?
Yes, sir.
A2 will be W2. W2 size is what? 3 to 4? And 2, 0.8, 0.8, 0.8, 0.8 divided by plus 1, 1, 1. How much it will become?
1.8, 1.8, 1.8, and 1.8.
So,
I think it will be something else.
huh?
3.2, 4.2, 4.2, 4.2.
Okay, 4.2, 4.2, 4.2.
Yeah,
So,
4.2.
Yeah. So now your H2 will become how much?
0.985.
Very good. 0.98, 0.98, 0.98. Okay. Now, what we calculate now? We calculate now we take W3. W3 is 2 into 3.
Hmm.
This how much it will become? 3.94, 3.94.
Yes, sir. 3.94.
Okay. Now, from here, you calculate H3. H3 is equal to softmax of 3.94, 3.94. This will become 0.5, 0.5. Okay.
Okay.
Okay. So this was the forward prop. Now I will cover the back prop now. And see, while calculating this, these values we have stored. So I know A1, I know H1, I know A2, I know H2, I know A3, I know H3. Okay.
Yes.
Now
Yes.
what is loss? Cross entropy loss is equal to summation of y into ln of y hat. Okay, y hat okay, what we had found, and y is 1 0. Okay, so this will become minus 1 into ln of 0.5. So this will be the loss. In case okay, you are asked about the loss okay. So this you can calculate easily.
Yes, sir.
Okay, now here I will tell you something. For example, here you are said that true y was 0. Okay, here I have given the y value 1 0. So, and there are two values only which can come 0 and 1. So how you will represent 0 and 1? 0 can be 1 0 1 and 1 can be 1 0. So please remember this, that if they give you true y is equal to 0, then also it means that there has to be one value 1. Now come to backward prop.
Excuse
Now,
me, excuse me.
yes.
I didn't understand that, but could you just repeat that part?
Okay. So there is a question that your output, they have given you that true y or true output value which is there, it is 0. Okay. It means it is a classification problem that either it can be 0 or it can be 1. Here we are representing that the output which we are getting, it is a vector of size 2. So if it is 0 also, remember that it can be 0 1 and 1 can be represented as 1 and 0. That I was covering. Is that clear? 0 does not mean 0 0. This was my point.
So 1 can also be 1 1, right?
No, 1 1 it cannot be.
Is
Okay.
this like one hot encoding or something?
One but on yes, you're right, absolutely right. Like for example, if I have to sorry, I will just give you an example that I have got a classification problem where I have to identify 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what will be my output, how it will look like? So 0 will be, for example, it will be 0, 0, 0, 0, 0. I will have 10 values and at one place I will have 1. 6, 7, 8, 9, 10. 1 I will say 0, 1, rest all 0. Here 2 will be 0, 0, 1, 0, 0. So it is like this. So what I want to say that if they tell you that true output is 0, It does not mean that it is 0 and 0. Okay, 1 will be 1. I hope okay, this concept is clear. You can see previous question papers, quiz 1 especially, where okay, this kind of confusion was there. So you should not suffer due to that. Now we come to the back propagation. Okay, forward propagation is clear. How we calculated y hat, and from y hat how we have calculated the cross entropy loss, that we can do easily.
Sir, for cross entropy loss, we should always use natural logarithm, right?
Yes, yes, always, always.
Okay.
Okay. Now we do the back propagation, and just pay attention. If you understand this concept, then your life will become easy. What is the objective? We have to understand. Objective is to update weight vectors W3, W2, W1, and the bias B3, B2, B1. Forward propagation, we move forward. In the back propagation, we will start moving from back. So first we will update W3 and B3. So now using the chain rule, now I know update is W3 is equal to W3 minus eta into loss with respect to W3. Take eta is equal to 1 for simplification. So it means I have to calculate this value. Similarly, I have to calculate B3, these two values, to update W3 and B3. So how to calculate? So see WL by W3, I can write as WL by WA3 by WA3 by W delta W3. Is this chain rule clear? Now, delta L by delta A3 for a softmax function for a cross entropy loss, remember this, it will be y hat minus y. And delta A3 by delta W3, this partial derivative, we know A3 is equal to W3 into H2 plus B3. So dou of A3 by dou W3 will become H2. So this becomes H2. The dimension of this dou L by dou W3 has to match with W3. W3 size is what? 2 into 3. Now see here, y hat minus y size is 2 into 1. H2 size is what? 3 into 1. So I have to multiply this by its transpose to get this. Is this clear, Akir? This part for W3? Any doubt? Anyone? Please pipe up.
The loss function we are using is MSE, right?
MSE for the cross entropy also, it becomes y hat minus y at A3.
Okay.
Okay. And for dou L by dou B3, it will not have H2 because here it becomes 1. It will become y hat minus y. So we have finished both W3 and B3. Now we can update W3 and B3. We are done. Okay, so question will be asked like this. Okay, now we move to what? We move to B2 and W2. B2 and W2. So dou L by dou W2 is equal to dou L by dou A3 by dou H2 by dou H2 by dou A2 by dou A2 by dou W2. This already we have done. This is y hat minus y, which I have told you also to remember. Okay. A3 and H3, A3 is equal to W3 dot H2 plus B3. When I take derivative with respect to H2, it will become W3. So here I get W3. H2, A2. H2 is equal to sigmoid of A2. We know that when we take H2 dash, it will become sigmoid of A2 into 1 minus sigmoid of A2. This is a derivative of sigmoid function. and this is nothing but H2 into 1 minus H2. So here I get H2 into 1 minus H2. Dou A2 by dou W2, it will become H1 because A2 is equal to W2 into H1 plus P2. From here I get this value. Is this clear, this part? Now we have to match the dimensions. W2 dimension is what? 3 into 4. This dimension is what? 2 into 1. W3 dimension is what? 2 into 3. H2, 1 minus H2 dimension is 3 into 1. And H1 dimension is 4 into 1. So when you will put this, it will become W3 dot y hat minus y into, this is element wise multiplication, H2 1 minus H2, and this whole, if you match the dimension, it will become 3 into 1 dot H1 transpose. So here this is the value of W2. This we have done. This is clear. And for the B2,
The W3 is the transpose.
W3 is the transpose 3 into 1.
W3 is 2 by 3.
Yeah, 2 by 3. So 3 by, you are right. Thank you, Anand. Thank you so much.
Sure, yeah.
Okay. So that's why I had covered earlier that if you are using W in forward, then you will have to use W2 in backward. Okay. And for WL by WB2, only this part will come, because H1 here, when we take derivative, it will come 1. So here will come this. So this we have done. Here we have come. Now similarly, you can go ahead and you can find WL by W1 and del L by del B1. That also can be. Any doubt in this back propagation? I will do one thing. I'll share one document tonight only, in which all these steps which are they are given clearly. So in the question quiz 1 from the week 3, a question can come that there is an input, the weight values are there are hidden layers, weight values are there is another hidden layer, weight values are there, and given true y is this, input is this, find loss. Okay. Second, you find del L by del A3, or you have to update W3, or question can come that W3, please find the first second row, first element. These kind of questions they have been asked. Okay. So this you can do. I'll be sharing this document also, and there is one document, okay, which is there on this entire artificial neural network, including forward and back propagation. That I will share with you. Okay, there was this question. So this
Also share this document, sir, with us.
Yeah, I'll convert it to PDF and I'll share with you. Yeah. So any other question, any discussion, anybody wants to discuss anything?
So I had a question from the previous year paper.
Yeah. Do you have? You want to ask?
Yes, sir.
Which one?
So last year's paper, the last term's paper.
Yeah.
Do you have it, sir, with you?
I can open it. I can find out.
So I can just dictate the question. It's not that big of a question.
No problem. I will, this is January 24, no?
Yes, sir.
Okay.
It's page number 41.
Page number 41. Okay. Okay, this is the question.
No, sir, 48.
48. Okay.
So on page number 41 only, the question number 48 was there.
Okay.
Yes, sir.
Okay. This is the question.
Yes, sir. This
Quadratic loss function. Yes. Okay. One iteration. This visible to everyone?
Yes, sir.
Okay. Okay. So loss function is this. W represents a model parameter. Momentum based gradient descent to minimize this loss. Momentum parameter is 0.9. Learning rate is 0.1. Initial parameter value is of W is 0. What is the updated rate value after one iteration? So what all concepts which you have to use here? Beta has been given 0.9. U minus 1 will be 0. LW is W minus 4 square. Therefore, del L by del W will be 2 into W minus 4. This has become. So, initial parameter value W is also 0. So, W is equal to W minus mu into. First, we have to find U0, first iteration. This will become beta into U minus 1 delta 0. W is equal to 0. This becomes 0. So gradient at W0 and W0 is equal to 0. So here U0 will become minus 8. Is it clear?
Yes, sir.
Yes, sir.
Okay. So now your new W will become W minus mu into U0. W is 0. U is 0.1 into minus 8. This will become 0.8. So this is the W. Is that correct, Kya?
Yes, sir.
Okay. So have you got the concept, Kya? How I solve this?
Yes, I got it.
Okay.
Thank
Yeah.
Sir, could you scroll down? There is a question, right? W1 equal to W2 equal to W3. Could you just show the solution?
Okay.
And
Another
in
question.
there, no. In your notes itself.
In my notes, which one?
W1 equal to W2 equal to W3. I think it's yeah, this one.
Okay, so this I was solving, but however, somebody shared this question with me without the back information. So in this question, it has been given that sigmoid which is using, they are using the function 2 over 1 plus e minus z. Okay. So I use this. Okay. So here the question is, for example, but I will cover conceptually. So this kind of question can come. So, for example, they have given W1 is equal to W2 is equal to W3. These are the values. Okay. They have given A1, they have given A2, they have given A3, and they have given true Y. Okay. Use cross entropy loss and compute the gradient of W10 of W3. Means second row, first column. Okay. So how to solve it? So what do? First you find H3. H3 you can find from A3. It will be the softmax of A3. So this will become this. Always remember in softmax, whenever these values are equal, you divide 1 divided by the number of them. So you'll get 0.33, 0.33, 0.33. Okay. Now H2 is equal to sigmoid of A2. So I used a standard sigmoid function and I found 0.95, 0.94, 0.95. Then I know, just now I covered during the back propagation, that gradient of loss with respect to W3 will be y hat minus y into H2 transpose. Y hat minus y, H3 is y hat. So y hat minus y is 0.33 minus 1 this, and transpose of H2 I've calculated. So I get the gradient of this W3. And this will be the W10 of W3. Okay, so these are the steps. Only thing was that sigmoid decay which has been used, it is here 2 divided by this. So the values of this H2 which are there, they will change. Rest everything will remain same. I think this is also from previous questions.
Yes, sir. Got it. So there is also a similar question in the Jan term itself,
Okay.
where W1 to W3 is equal, and I think my answer does not match. Could you see once?
Okay, so I will just go to that question.
Yeah. So I think it's like W1 equal to W2.
Is this the question?
Yeah. Yes. We have to compute the cross entropy loss.
Okay, so I will take this again. Let's solve it. Okay, so here they have given neural network with 2 hidden layers. So first we make the architecture of this layer 1, 2, and 3, 4. H1, H2. One output layer. AK is a pre-activation and HK is the output from the kth layer. Okay. All the neurons are use sigmoid. So hidden layer all are using sigmoid. Neural network is used for a classification problem with 3 classes. So these are the 3 classes. So here it will be using softmax and output will be 3. So like I said, okay, it can be 001, it can be 010, it can be 100. So these are the type of outputs which we are looking for. Number of neurons in each hidden layer is 3. 1, 2, 3, 1, 2, 3. We have only 3 neurons in the output layer. We have to have, because the output has to look like this. Suppose that the weights are this. True label for the input is this. 1 hot for input weight y is this. Assume the output layer uses softmax function and this. There is no bias.
So y will be 100, right? Because it is already given.
Yeah, so y is 100. So you do one forward prop, okay, you do that. So they have given 001. So what do you do? W1. 1, 1, 1, 0, 2, 1, 1, 0. So your H1 will become sigmoid of this. Can somebody give me sigmoid of this?
So sigmoid of 0 would be 0.5, right? And sigmoid of 1 will be, let me see. .26. 1.
0.26. 0.26. So this is your H1. Now your A2. Again 1, 1, 1, 0, 0, 1, 0, 1, 0. Into 0.26, 0.26, 0.5. This will become how much? 2626, 52, 52.
So it will be like 1 point. I did actually calculate this, but again,
yeah,
I was having some issue. Please.
This will be this. So your H2 will be sigmoid of this 1.02. So it will again come 0.26 around. 0.5.
Right.
0.5. Can you give me 0.5 figure?
0.5 sigmoid, right?
Yeah.
So, it's 0.377. So you can take 0.38.
Okay, and 0.26?
0.26 would be 0.43.
Okay, so this is your H2. Now you come to
Right.
A3. A3
Mhm.
1 1 1 0 0 1 0 1 0 0.26 0.37 0.43. So this will become 6 7 13 3 16 2 1 3 3 6 4 10 1.06. This will be 0.43. This will be 0.37. Now, what do? You find the softmax of this.
Mhm.
Okay, so you'll get some values 1.06, 0.43. There's one another. Can you give me this figure second? Were you getting
So
the same values here?
yeah, so I think let me just check some minutes.
Yeah.
So I think after that, taking the softmax and getting 0.30. But again, could you calculate? I mean, I might be making mistakes.
69, 16. Calculate again. Give me the softmax value.
Okay. So I'm getting like array of 0.305 and 30, then 0.34 and then 0.35.
Okay, Bhavya, can you give me this? 4337 1.06. Okay, let me calculate this. Okay, what
Actually, how do we calculate?
Just hold on. Okay, so what are the values were there? E2 power 1.06, then plus E2 power was 0.36.
Yes. Yes. 0.7.
E2 power 0.47.
Right.
0.48. No. It's 37 and 4. 37. 48. So 0.49 is 1. And this will become 124. And this will become how much? 0.437. Okay, these are the values which you got.
Yeah, so there I think I am making mistakes, so that might be so this is correct then. And then we will take cross entropy of the because it is
So-
100, so log of 0 minus log of 0.4, which is
So this
right.
will become 0.49. Okay.
I think
This
the
is
second and the third got interchanged, Lalit.
Which one?
I think 0.24, this 0.24, then 0.27.
Yeah.
I think 0.27 should be on the top.
0.24 is for 37. Yes. Sorry. But they don't make any difference because this is the only.
Yeah, they don't. Yeah.
Yeah. Because I want the first one, right? So
Yeah.
Right.
So then we can see the later parts also. So in quiz 1, you can expect a question which will have full like this, full one. They will not give you the entire that to calculate W1 also and B1 also. However, you should be able to calculate at least for W3 and B3. Okay,
Right.
because that is simple like here. So now here use cross entropy loss and compute the gradient of W10. So that we have seen here.
Yes.
That should not be any problem. So that will be, so this we can calculate WL, W3 is equal to y hat minus y into H2 transpose. And from here, okay, we can find out.
Yeah. So after that, there is no issue. If we have done the forward pass, then backward pass
Yeah,
is not.
yeah. So yeah, so this again becomes easier. So if your fundamentals about forward prop and backward prop at least till outward the last hidden layer. Here again your fundamentals they should be clear.
Right.
Okay.
So one question regarding the forward and backward. So if for a backward calculation, we first need to calculate the forward propagation, right? Then only we go with the weight update.
Yeah. See, generally what do we do in the algorithm? We make the forward pass. We store these values because these values will come handy when we do the backward pass. But it is not mandatory. Okay. Because in one of the question, I think in GA, the question was about the English. Is it mandatory? So it is not mandatory. Normal convention is that okay, we store these values, we use them while backward pass. However, it is not mandatory. While okay, doing backward pass also, again we can calculate and we can use these values.
But we can use those value if it is being given. We can use those value, right? That's the So it is not mandatory, but we can calculate to the back propagation. That's the point, right?
Definitely, like we have been doing. Okay. We are making the forward pass. We know these values, and then we are using these values for our
back
updates, backward pass.
Okay.
Yeah.
Sir, can you please scroll up a little bit?
Yeah.
So in this, the H1 sigmoid, right? So for one, I'm sorry if this is silly doubt, but I'm getting 0.73, and I opened the calculator.
So I had asked someone, okay, he gave me that. This figure I have not calculated. I'll check it.
That's what I was confused.
I will check it again now. So this was sigmoid of what was the value? 1.
So minus 1.
Minus 1.
So we'll take minus 1, right?
Yeah, minus 1. So 0.73. Yeah, you're right.
Thank God.
But here it is 1 okay, it is not minus 1. Huh? Okay. Understood.
But in formula it is
yeah, understood. So he has given me wrong. Okay. So entire everything has gone wrong. So what you do?
Okay, method is clear to me, but this is where I was confused. I was like, how can I be this wrong?
Yeah. So what you do, I will suggest to all of you at least solve these kind of questions. It will give you a lot of confidence. You have got still we have got Saturday, and it will give you a lot of confidence. And this concept will come very, very handy in coming weeks when you will be doing CNN and when you will be doing RNN. And if you understood these concepts, then those concepts will be very, very, I will say, very easy to understand, to comprehend. So build up your basics on that here.
Sir, where can we find the previous year papers?
Previous year papers that I'm also not sure. I got one paper, last one. So there are some links in your WhatsApp groups, student WhatsApp groups, which are there.
I will post it right here.
Yeah.
Yeah, sure.
Yeah. So,
sir, final question: will the recording be there for this session?
I have done the recording. Yes. I will just check it whether it is happening or not. So definitely, no. Actually, I am not the administrator of this meeting. So I have requested the administrator if the recording is taking place.
A meeting has been recorded, sir.
Yeah. So this notes I will convert to PDF. See, due to in calculations there might be some errors, like somebody pointed out here. Okay, but just go in the concepts at least these questions which are there.
Please don't erase, sir.
What?
If you're not making it correct, then don't erase.
No, this was incorrect. No? That's why I have erased these values. Okay. Otherwise, if somebody gets these notes, he will be flabbergasted. Okay, from where this value has come. So that's technical.
Sir, when you are going to post these notes?
By tonight, definitely.
Thanks a lot.
Yeah. So if there is no question, can we call it off? And I wish you all the very, very best. Take care for quiz one. Keep yourself cool. Understand the concepts. Understand which concept to utilize there. Where. Okay, there might be some tricky questions, but believe in your abilities. Believe in your conceptual thinking.
Sure, sir. Thank you.
Really good
For the
class,
session.
Lalit. Really
Thank
good
you.
class. Very
Thank
good.
you, thank you, Anand. Thank you
Yeah.
so much.
Yeah,
It's
really helpful. Yeah, thank you so much.
Where will you be posting these notes?
These notes I will put in the discourse. Okay, I'll make a new topic, revision notes, okay? And just give me half an hour and they will be there on the discourse in deep learning.